Okay, I believe we're back. First off, I'll give you a general overview of what I'll be talking about. First, I'm going to define what big data is to the best of my ability, and then I will go into a little bit more detail into how it is used, and I'm going to finish off by explaining why this topic intrigues me personally and what implications I see it having for my personal future. So um, I will start off with the basic definition. So we have big data, and so I'm sure if you are any what that's not the correct words. I'm sure if you are familiar with anything in the science community or in the business community or anything, you've heard these words together. Now, the big names in big data are Google, Amazon, and I believe Walmart has a lot into it. And so, basically, what big data is, it's just a sort of vague uh, category of data collection for having a large warehouse of data, maybe from many different sources. So you have all these spreadsheets and warehouses of data being coagulated into one giant source of numbers and statistics on anything. So the way this applies to the big names in big data, if you look at Google, for instance, Google can track. Well, the one that's obvious is how much people are searching a specific word or buzzword, and then there's other ones that are also important. So a lot of things like Amazon will track how long you'll hover over specific buttons before you click on them, or if you don't click on them, where you are looking on the page based off of where your mouse is, because the web page knows where your mouse is for things like the little like pop up bubbles that when you hover over something, something pops up. The code has to know where your mouse is for that to happen. So what a lot of companies are doing is they are tracking where your mouse goes, and they're keeping it specific to your IP address and your computer, so that when you come to that website the next time, it is more streamlined for you. So a lot of these ideas can be scary in a sense, coming from a especially to people in the older generation, because they don't really see the benefits of this coming on the horizon. Now, I agree that there is a lot of privacy questions and moral questions that come along with this idea of tracking everything, because that much information could be used in bad ways, obviously. But so basically, a general definition of big data is just many data points and many statistics being taken in and stored from many sources into one gigantic data warehouse. This can be in the cloud. This can be just on a company's personal computer farm. This is just a big storage of bits and bytes that um, that has a lot of implications into our future. So why does this have implications into our future? Um, so what companies can do with these data points is create models of the average consumer. And this doesn't just apply to business. It's easier to explain it from a business model, and I'll explain some more applications afterwards. So a company can say can keep track of a specific customer, and not necessarily one specific customer. So it's not like Amazon has a tag on you and is specifically watching you. They're watching everyone. And the thing is that they can form a model of the average consumer and tailor their website to that average consumer. But not only that, because they can keep track of a specific consumer individually, so they can say, okay, this IP address is looking at the website, what did they do last time? They can look at the entire history of that consumer's viewing of their website, and they can use the data that they have to build a model of what that consumer will do, so that they can streamline and personalize the experience on their website for that consumer. So let's say that I'm pretty big on fishing. So let's say I was looking at fishing stuff on Amazon. So now that Amazon knows that, Amazon can start tracking where I normally look on web pages and start putting specific ads here on the web page, because maybe I tend to look at that specific spot of the web page more. And they'll say, hey, there's a big deal on fishing stuff. Come look at it. So we got our fishing rod, and you're catching a fish. So then me as a consumer, I say, oh wow, that's a neat coincidence. I was just looking at fishing stuff, and then I click on it. And so now they've got me because I am interested, and they've also followed up on what I've looked at in the past to reel me in with a metaphorical fishing rod of business advertisement. But this doesn't just apply to advertisement, because they can establish an emotional connection with the consumers, because they can start sending emails that are specifically tailored to a consumer. And the analytics don't stop there, because the data collection continues when you open your email. They can email providers like Google, Gmail, and actually any email provider really has the capability of tracking, one, whether you've opened the email, how long you look at an email, how long it takes you to scroll down the email, where your mouse looks on the email, how long the mouse stays on a specific spot. There's so many data points that a company can track based off of in just one simple email that they send to you. So they can find that maybe if you're a person that just deletes emails, you are no longer someone that they are interested in pursuing. Now, if you are someone that maybe unsubscribed from the email, then there's always those little surveys once you click the unsubscribe button that say, what is the reason you unsubscribed? Because you were getting too many emails, things like that. And they can use that data, maybe not on you, but on a similar consumer, to better their experience with their product and with their presentation of advertisement. So this is a big step in terms of the business side, because now it always seemed like business was trying to like trap the consumers, and it always seems like the business is out to get you. But now businesses can actually understand the consumers and connect with them, so that they can actually tailor the experience to be better for a specific consumer. So now you may think, how can someone tailor an experience to a subjective notion? Maybe I don't know, if I'm trying to think of a good example, but so there are a lot of subjective data points that you can't necessarily put a number on. But the thing is, if you create a strong enough model, then you of a consumer's behavior, you can predict when a consumer is going to do something, and you can be ready for them so that you can maybe get a consumer's attention when they're actually looking. So this can apply to emails. If someone tends to read their emails at a specific time, then let's say Amazon may send them an email closer to that time so that they're more likely to be read and their advertisement is more effective. So there's a lot of things that this data collection can improve in terms of efficiency of processes. But more importantly, this big data aspect has a lot of implications into other more day-to-day industries, maybe the medical industry. Let's look at what kinds of big data could be in the medical industry. Well, we have completely mapped the human genome, and we've also and are constantly mapping more more genomes of other people. So, and people are constantly coming into clinics and with symptoms, and there's lots of problems with cancer and whatnot. So what big data analysis can do is, if it clumps all this data into a big warehouse and starts to build models of maybe the symptoms of a specific virus or something like that, then then when a patient comes into a clinic and starts listing off symptoms, all a doctor will have to do is start plugging in these symptoms, and then this model or this algorithm will pop out an answer saying, hey, these are the percentage chances that this person has all of these problems. And now there is another side to this. So I read a book on this whole topic recently. So because of all of this data collection analytics, it's starting to look as if the human worker will be put out of work soon. But the truth is that the humans in general tend to evolve to the situation. And what will become more important is that emotional connection. Because like I said, although models can be created, it is difficult to idealize a subjective idea and concept into numbers. So then there will always be a need for that emotional connection of the doctor. And there's also the idea that maybe the information is invalid. So a patient may come into a clinic with claiming all these symptoms, and you need to have a doctor that can see through the veil of ambiguity and see the real picture. But in terms of quick action, quick diagnosis, the computers will always have us beat. And this big data idea is what is actually allowing for this improvement to the medical the medical industry. So like I said, there are a lot of things like, so we have search engines like Watson, this AI technology, who is helping in hospitals with quickly searching databases, finding patients' records and whatnot, so that diagnosis can be quickly. Okay, so a situation can be quickly diagnosed, so that medicine can be applied when it needs to and not retrospectively. So this is important for things that can become more dangerous and more costly as time goes on, like cancer. If cancer is found fairly quickly, it is treatable in most cases nowadays. And although we are still the dream is to find a cure for all cancers, treating it is also an important idea at the current moment. So this big data idea can help us diagnose things very quick and start applying treatments before more costly, more dangerous treatments are necessary, and before you hit a stage of cancer that is that you can't come back from. So it there's a lot to take in with this idea, and there's a lot of promise, and like I said, there are some scary aspects to it because of that lack of privacy. But I wanted to show how this applies to my future and how I am excited for this idea. So, as we know, I have done a lot of work in AI, and although I am currently at somewhat of a roadblock, I am pretty happy with what I have created so far. Now, I don't think that this next step is on the doorstep per se of my career, but I do think that I will be able to at least begin um, working on this project in the near future. And so the project I'm talking about is slightly adjusting my current AI, or perhaps after I test around with the deep, what was it, the deep learning AI, I can tailor that program to begin writing models from large databases and start. So I can get my AI to start data mining these data warehouses and creating these models so that numbers can be plugged in and um, inferences can be made on a variety of different categories. Now, I myself don't have expertise in a lot of different business aspects and medical aspects, but the thing is that if I and the AI if the AI and I were to team up with someone that has that expertise and that experience, my numbers could help them make more accurate inferences or more timely inferences on a given situation. So the what I plan to look at is, let's say that there are all of these different variables and whatnot that are statistics in the warehouse, and so these are going to be inputs into my AI, just like how this is similar to the picture I was drawing for the deep learning, um, the deep learning AI. So now my AI can go in and first off see which one of these. Well, let's not take this from an intuitive approach. Let's take this from the AI's approach. So the AI can come in and randomly start making formulas. So let's just say x plus y squared plus ln of z is equal to n. So let's just say the AI makes this random equation and it assigns this x, this y, this z. So, and n being our answer or our output. So the AI can assign weights based off of maybe a quadratic system or maybe a coefficient. So it could be like 2x plus 4y squared plus 5 ln z. And these random weights would be forming this model of popping out a percentage point of a specific statistic. So let's say our statistic was, this applies to a class I'm taking, so I'm going to use this example. Let's say we have a sports stadium that's selling tickets to the game, and they want to know what is the percentage chance that a customer will come back to the next game and buy a ticket. Because this is important. in a business model, you want reoccurring customers so that, especially for this big data system, you can start tailoring the experience to these customers so that they may want to spend more money, they may want to come back more, they may want to bring friends, and so on. So our n here is going to be the percentage chance that consumer will rebuy. And so this is a very important number, because this can very significantly change how you will advertise with that specific customer and whatnot. So let's say we had an n, that's an m, an n of maybe 0.05. Now this means that a person is very unlikely to come back and buy another ticket. This is a 5% chance. So I mean, there is some chance that they will come back, but there is a very small chance. So it may be a good idea for the company to simply leave these people alone. Now, on first thought, you may want to think that you would focus on these people because these are the people you are going to lose. But given that this person has such a low chance of wanting to rebuy a ticket, there may be no chance of changing their mind. So this person is a no-go. You don't want to put any effort into them. They are a lost cause. So then we can consider maybe an n of 0.95. And so then this is the opposite case. This is someone who is very likely to rebuy. And it turns out that similarly, you shouldn't really look at this person either, because they are very likely to rebuy a ticket on their own, so you don't really have to do anything. So this person you don't have to put any effort into. So what numbers are important? Well, if you look at someone who has maybe an n of 0.65, so if you have a 65% chance of this consumer coming back to rebuy, then it's a significant jump in profit if instead of 65% of these people coming, you get maybe 85% of these people coming back. And so these people who are sitting on the fence, metaphorically, are the ones you want to focus on. So what did this do? This took an entire population of consumers and it narrowed down the people that you have to go send out emails to and start nagging about buying a new ticket. Or perhaps these are the people that you randomly send a promotional coupon or say, hey, why don't you try this out for the next game? And you can get these people to come back, and then they will be hooked because they've come twice, or something like that. So these are the kind of statistics that can come out of these models, but it would take a long time if for some reason this was the model that I needed. This would be a very simple model, and it already looks pretty complex on its own. Imagine if there are 500 inputs that are necessary for an accurate model. So what the computer can do, and what my AI will hopefully be able to do, is to look through these inputs, randomly assign them into weights and multiplications and whatnot into this gigantic equation, and form a model that through genetic evolution will get better and better and better at representing this statistical value we've talked about of n. So, but it's not just restricted to whether a consumer will come back. This could be applied in any direction. Maybe you want to see how likely someone is to bring friends. Because if someone is likely to bring friends, then maybe you'll start giving them a free ticket every once in a while. So they'll pull in a new consumer base. So this has a lot to do. There's a lot of implications with these models that computers can generate, but I think that my genetic AI has a good shot at, if not quickly, at least creating a more sophisticated model than I would just through simple intuition, because I don't necessarily understand the industry that a specific warehouse of data may apply to. So that's the general overview of big data. And this is something that I will be planning to look into the future, because I think this is something that I could actually apply into a career. This is an idea that could possibly be used if maybe a let's say a restaurant were having trouble advertising to the public. I could come in as a consultant, analyze their consumer base through surveys and whatnot, and apply that data into a into my AI to form a model of their consumer base, so that I can now help them with decisions in terms of where they want to advertise and what kind of advertisement they want to talk about, what promotional ideas, maybe partnerships. So that's the idea that I'm working with, and I'm kind of tossing around in my head. It does seem intriguing, and it does seem like a very possible and fruitful career for me, at least in the start. In terms of what I want to do with my career, I would like to start my own business. And that is something, one of the reasons that I started this channel is because I want to, one, force myself to keep working on my AI, which has been difficult lately just because of the roadblock, but I am getting by. And two, to kind of slowly get my name out as a person that is that knows what they're doing in the realm of programming, in the realm of AI, and in the realm of logical thinking in general, because in a crazy world that can put three people that maybe not anyone wants to vote for on the ballot, I think logic is a valuable asset to have in the coming future. So that is all I have to say on this topic of big data. I am going to move on to my usual segment where I draw something. This will be the first time that I am drawing with the pen tablet, so that is exciting. So stick around. I have a short ad while I get ready, but I want to thank you for watching so far.